Hi, and welcome to the video on nonlinear simultaneous equations. Here we're asked to solve simultaneously xy equals 6 and x plus y equals 5. What this means is that we want to find values for x and y that make both of those equations true. We begin by labeling xy equals 6 as equation number 1 and x plus y equals 5 as equation number 2. This means that we can refer to it throughout our working out as 1 and 2. Now we want to rearrange one of these equations and then substitute it into the other. To do this, we're going to start with equation number 2 because it's the easier of the two. What I'd like you to do is to pause the video and I'd like you to rearrange the second equation so it's y in terms of x. Okay, if you did that correctly, then you would have subtracted x from both sides of the equation and you would have gotten y equals 5 minus x. This gives us a third equation that we can substitute into our first equation. I want you to think for a second, why wouldn't you substitute the third equation into the second? Well, why don't you take a piece of paper and see what happens when you do substitute the third equation into the second and see what comes up. I think you'll be interested in the answer. But what we're going to do in this video is substitute the third equation into the first. That means that wherever I see a y, I'm going to replace it with a 5 minus x. This gives me x multiplied by 5 minus x equals 6. From this point, I want to try and solve for x. So I'd like you to try and pause and see if you can solve for x from this point. Okay, if we did it correctly, our first step would have been to expand the bracket. This would have given us 5x minus x squared equals 6. My next step would be to write it in the general form. To do this, I want a positive coefficient of x squared, and I also want my equation to equal 0. This means that I'm going to be adding x squared to both sides, and I'm going to be subtracting 5x from both sides, giving me x squared minus 5x plus 6 equals 0. This is now in the general form because I have all my terms on one side equaling 0 on the other. My next step is to factorize. This will help me solve for x. Now, you could use the quadratic formula at this point, but it's easier to factorize if you can recognize the binomial that will solve this correctly. The binomials will be x minus 2 and x minus 3 equals 0. You can try and expand those two binomials and see that you do get x squared minus 5x plus 6 equals 0, but I'll leave that for you to do by yourself. Our last step is to try and solve. Now what this means is that when we multiply x minus 2 and x minus 3 together, we get 0. This means that one of them has to be 0. Either x minus 2 will be 0 or x minus 3 will be 0. This gives us two solutions for x. If x minus 2 equals 0, then x will be 2. And if x minus 3 equals 0, then x will be 3. These are our two solutions for x for our simultaneous equations. Now what we want to do is get a corresponding y value in order to solve it fully. So what I'm going to do is I'm going to substitute x minus 2 and x equals 2 and x equals 3 into this third equation. I could have chosen any of those three equations, 1, 2, or 3, but it's going to be easier to solve if I choose the third equation. What I'd like you to do is to pause the video at this point, substitute x equals 2 and x equals 3, and get a corresponding y value for these two x values. Okay, if you did it correctly, here's what you should have come up with. Y will equal 5 minus 2. That means that y will equal 3 when x equals 2. And y will equal 5 minus 3, which means that y will equal 2 when x equals 3. These are our two solutions. Right now though, you have working out on your page. What we want is to write a solution that is easily accessible to the reader. So we finish off with a therefore x equals 2 when y equals 3 and x equals 3 when y equals 2. Why don't you go back to the original questions and see if those two solutions work? When x equals 2 and y equals 3, does it work for both of them? And vice versa. Now we're going to try and solve the second equation. This is a little bit more difficult, but we'll go through it step by step to help you out. The first step is the same as the last question. We're going to rewrite our equations and we're going to label them equation number 1 and equation number 2. We're also going to rearrange equation number 2 so that we can write it in y in terms of x. Again, I'd like you to pause the video at this point and see if you can't come up with this step yourself. If you did it correctly, then the first step would be to add 4y to both sides of the equation, and you would get 4y equals 3x minus 20. and then we would divide both sides by 4 and get y equals 3x minus 20 all over 4. Don't worry if you got something like 3/4 x minus 5, that is also acceptable, but I'm going to leave it like this because when I substitute it into my calculator, it's going to do the same job anyway. This is now my third equation, and I'm going to substitute my third equation into my first. Again, as an exercise, you might want to substitute the third equation into the second and see what you come up with, but we're going to substitute the third into the first. To do that, I get x squared plus, now wherever I see a y, I'm going to substitute 3x minus 20 over 4 into it. But notice the squared, that's really important. That equals 16. I think at this point, although it's very difficult, I think I'd like to see if you can pause the video and challenge yourself to try and solve for x in this situation. Okay. If you did it correctly, then the first step would have been to expand that bracket by squaring both the numerator and the denominator. If you expand the numerator and the denominator, you should get an equation that looks like this. X squared plus 9x squared minus 120x plus 400 all over 16 equals 16. Now at any point in this working out, why don't you try and pause the video and see if you can't go on to the next couple of steps yourself. But my next step after this one would be to multiply all of my terms by 16. That's the denominator in my fraction. If I multiply all three terms, that is, I'm going to multiply the x squared by 16, this fraction by 16, and this 16 by 16, what I end up with is 16x squared plus, now that's just the numerator right here, 9x squared minus 120x plus 400, and that'll equal 256, which is 16 times 16. What I'm going to do now is I'm going to gather together these like terms, so I get 25x squared minus 120x plus 144 equals 0. That's my general form. And now I want to solve for x. Now, it's completely up to you how you do this. You might like the quadratic formula and substitute that into your calculator and get an answer. However, I personally like the factorized version because I notice that this is a perfect square, that I can rewrite 25x squared minus 120x plus 144 as 5x minus 12 all squared. If you're clever enough to see that, then you might be able to go on to the next step, which would be to square root both sides and get 5x minus 12 equals 0. You would add 12 to both sides, and then you would divide by 5. This gives you a value of x equals 2.4. Now, in this particular solution of this nonlinear simultaneous equation, there is only one solution. Now, I know we're used to having two solutions, but in this one, we're only going to have one. So what I want to do now is I want to substitute that one value of x, which is 2.4, and I want to substitute it into my third equation. Again, I could substitute it into any of the three, but this is just going to be the easiest way. I'd like you now to try and pause the video and substitute x equals 2.4 into the equation. Alright, if you did it correctly, then you would have gotten y equals 3 lots of 2.4 minus 20 over 4, which gives you a value of y equals negative 3.2. Which means that the only solution for these two simultaneous equations, these two difficult simultaneous equations, is that x will be 2.4 when y equals minus 3.2. And that's it. Why don't you try substituting these values into the equations to see if you got it correct? Good luck.